Today we're going to be finishing off, well, we're going to be starting to finish off with the last topic. The last topic, which is called the binomial theorem, is covered over 2 days, today and tomorrow. When we get back, we will be reviewing on Monday and Tuesday, and then your unit exam will be Wednesday. That will give us 3 full days to have year review before we write an in-class exam. Replaces your lowest exam mark. And then we'll have 1 more day after that to just go over a few things. And the evening of that last day of classes, I think your diploma exam is the very next day, isn't it? So that evening, that day from, I haven't decided whether it's 3:45 or 4, probably 3:45 to whatever time, probably 2 or 3 hours. I'll be going through a cram session to get you ready, even more ready for the diploma exam. Can you do me a favor, please, and put up your hand if you were not here yesterday? So this written response question is assignment number 6. I know that it says on there that it's due tomorrow, but what I told people yesterday is that it's due when you return. I will take it in as late. Anybody else? As late as the Tuesday of the day we get back. But just some advice. Just because I say I'll take it in as late as Tuesday, that doesn't mean I think it's a good idea to leave it until after the holidays, because you might have even totally forgotten about it. Anyway, if we take a look at the screen here, I want books open, please, to the combinations problems that are in a couple of sections in your handout. A combination is a selection of items. So you're just selecting some items. It's how many ways can I pick 3 of you to go out for ice cream with me. Okay, it doesn't matter which order I pick you in. And that would be however many people are in the room, 2, 4, 6, 8, 10, 12, 14, 16, I believe 16 if I counted right. That would be 16, choose 3. As opposed to the number of ways that if I had 3 gift certificates, 1 for Tim Hortons, 1 for Earl's, and 1 for BP, the number of ways I could give those out to 3 individuals in the room, assuming that nobody gets 2 gift cards or 3 gift cards, that would be 16 P3. And we saw that what's different is that you end up with more arrangements than you do combinations. And you end up, specifically in this case, you're going to end up with 6 more arrangements, which are the permutations, 6 times more than you would combinations. And that's why for combinations you need to divide by the number of items you're choosing factorial. And we also have this weird notation at the bottom. That is only reserved for combinations, so you will never see that kind of notation with permutations. When you see that, that just means it's a combination. So 16 choose 3 could have been written this way. And by the way, I'm not really interested in evaluating either 16 choose 3 or 16 choose P, because if you wanted to, you wouldn't use the formulas, you would just go to your calculator. Okay? Can you take a look, please? We'll just do this in sections first. Part A, there was a section. Go ahead. Number 7? So, first of all, and I don't know, did I put a note on there about playing cards? It deeply saddens me to learn that there are people your age who have never actually held a deck of cards and don't know what the cards are. But are you familiar with a deck of cards? Okay. So if we're going to determine how many different 6-card hands are possible, if there are no restrictions, the answer to A is 52, choose 6. That's it. And it goes back to what I said yesterday. Don't overthink the combinations. You need to choose 6 cards. How many different ways could you do that? If you take a look at B, only clubs, this is one where you can easily overthink it. There are 13 clubs in the deck. 13 hearts, 13 spades, 13 diamonds, 13 clubs. 4 suits, 52 divided by 4 is 13. And that means that it's that simple. It seems as though there should be more involved than that. But since there's only 13 clubs, the only card hands that have clubs with 6 cards would be choosing 6 out of 13. 2 clubs and 4 diamonds. Again, it really is easy to overthink this. 2 clubs means 13 choose 2, and means times 4 diamonds, which means 13 choose 4. This is fundamentally, Isaac, the same idea as where we talked about having 8 females and 7 males, and you need so many males and so many females. And by the way, I think you're okay with me not actually calculating these. No 7s. Well, if I take a deck of cards and I remove the 4 7s, I have 48 cards. And that would mean for D, it would be 48 choose 6. If you wanted to organize it slightly differently in your brain, you could say for D that there are 48 non-7s and there are 4 7s, and you need to choose 6 of the 48 and 0 out of the 4. That's a C. E, 4 10s. This starts to get a little tricky because it's a little more complicated than 2 clubs and 4 diamonds, because this adds up to 6. But if you want to get 4 10s, then that means of the 4 10s, you need to get all 4, and because it's a 6-card hand, of the 48 remaining cards, you need to choose 2. Only 1 jack and 4 queens. Well, again, excuse me, that doesn't add up to 6. We need 6 cards. So what you really need for F is of the 4 jacks, you need to choose 1. Of the 4 queens, you need to choose 4. And of the other cards, you need to choose 1, but it can't be a jack. Right? So I need to remove from 52 the 4 queens and the 4 jacks to get a total number of cards that are still in the deck that I could choose from. And that's 44. Choose 1. And an interesting way to look at it is if you look at this, I believe this is going to give you 4. I mean, think about it. You can have the 4 queens and the jack of hearts, or the 4 queens and the jack of clubs, or the 4 queens and the jack of diamonds, or the 4 queen and the jack of whatever one I didn't say, spades maybe. But then you have 1 opening in the hand still, and there are 44 other cards that it could be. So that's why we multiply that by 44. Other questions? Yeah. 10? Be aware when you see multiple choice questions where the choices are written the way these are, just because something is written the way it is doesn't mean that's how you might arrive at the answer. Okay? So I'm not going to worry about what the choices are. We want to have an executive committee consisting of a prime minister, a deputy prime minister, a treasurer, and a secretary, and we're choosing them from 16 council members. Now this is in a way, it's a trick question because it's a permutations question buried amongst a bunch of combinations questions. Because Ali being president and Jacob being, or not president, prime minister, Ali being prime minister and Jacob being deputy prime minister is different than if their positions were switched. So the answer to this question is ultimately going to be 16P4. And I might have talked about this before. I don't think I have actually. That's going to be the answer, which means it's 16 factorial over 16 minus 4 factorial, which is going to lead you to this answer. So I hope D is the answer. You might approach this differently, and there are going to be problems. There are going to be problems that you do where this next strategy makes more sense than just saying 16p4. There is absolutely nothing wrong with saying there's nothing wrong with you starting this problem by saying, of the 16 students or people, whatever, we need to choose 4 that are going to be on this committee. Right? There's nothing wrong with starting with that. And then saying, and I need to multiply by the number of ways that I can arrange them because of the positions. And that's going to give you the same answer as 16p4. And the reason is 16 choose 4 is the number of permutations divided by 4 factorial. So if we multiply it by 4 factorial, we get the number of permutations. And I use this approach, let me explain this to you with a different example. If I had 8 empty seats, we'll say, yeah, 8 is good enough. 8 empty seats on a bus, and I get 5 people that get on the bus, how many ways can they be seated? The correct answer is 8p5, because where they sit is important, and that's an arrangement. However, it doesn't make sense to me because it looks like we're arranging 5 seats, and we're not. We're arranging 5 people. Excuse me. That doesn't make sense to me because that looks like we have 16 seats and we're arranging 5 of them. It makes more sense to me, Danielle, to say, of the 8 seats, we are choosing 5, and we're arranging the 5 people. That, to me, makes more sense than we have 8 seats and arranging 5 seats. And sometimes, I don't know, does it make more sense to you that way? I think for a lot of people it will. But then again, if you think this way, it might be that this is the way the answer is written, right, on a multiple choice. Or it might be, this is an unfortunate thing, it might be that it's a numerical response question. I'll show you one that I've seen. I've actually seen this before. You're given a key, and 1 is C, and 2 is P. And you're told the answer to this question is that. So you have to pick a number for Y to say whether it's a combination or a permutation, which would be 2. So this would be 8p5, so it would be 825. But the unfortunate thing is, by them doing this, they've locked you into this line of thought, whereas you may think of it this way. So you still have to be able to say to yourself, is there a different way to do it? And I think for this one, you should understand that the number of combinations is the number of permutations divided by r factorial. So if you multiply by it, you get it. Have I helped you out there? Okay. Any other questions? Second part. Go ahead. 1? Okay. Athletic Council is going to form a subcommittee of 6 council members to look at a new sports program. There are 15 council members. Okay. So of the 15, I haven't read about the females and males yet or said anything. Of the 15, we need 6 people on the committee. And we want at most 1 male. What does at most mean? And this is in the curriculum, it says students need to know what at most means. At most means a maximum of or no more than. So what does that mean? It means that we can have no males, this is males, comma, females is my thinking. No males and 6 females, or 1 male and 5 females, but we can't have any more. And to me, remember when we did questions like this yesterday, we found the total and subtracted? For me, rather than getting the total and subtracting all of the other possibilities, I think this is the quickest path to victory. It's going to be, the females is 9, whoops, no, the males are 9, the females are 6. So if I want 0 males, I would have 9 choose 0, and I want 6 choose 6. Well, this is going to be interesting. Because there's only one way to get no males. If you work this out, this will be 1. This is going to be 1. 9 choose 0, there is one way to choose nobody out of a group of 9. You just sit there and you don't move. How many ways can I choose 6 people out of 6? One way. But then we need to add, of the 9 males, we need to choose 1, and of the 6 females, we need to choose 5. So this is 1 plus, this, by the way, is 9 if you think about it. You can use your calculator. How many ways can you pick one person out of 9? 9. This is 6, because for each group of 5 I pick, I leave 1 behind, and I can leave any one of 6 behind. So 9 times 6 is 54. The answer should be 55. And it is. I'm seeing some nodding. Other questions? 9C. C? Okay. So n choose 7 equals n plus 1 choose 8. I'm assuming you are looking for an algebraic solution and not just putting it in your calculator. So we're going to use the idea that something choose something is equal to that first thing factorial over the difference between them factorial and over the second thing factorial. I've made it symbolic because I don't have an r and I have an n plus 1. So what are we going to have for the left side? N factorial over n minus 7 factorial, 7 factorial, equals, here we're going to have n plus 1 factorial over n plus 1, come on, minus 8 factorial. Oh, that's n minus 7, isn't it? There's an n minus 7 factorial there. And we have 8 factorial. So this is n minus 7 factorial, which means that's gone. With the n factorial, let me clean this up and just write it as n factorial over 7 factorial. Well, I don't know. I'm just going to do this. No, I better write it out. I don't want to leave anybody behind here. What are we going to do with those 2 factorials, Kendra? Don't know. Okay, that's fine. Remember, when you have factorials that are different, the smaller factorial is always contained in the larger factorial. Okay? And that means that if I expand the larger factorial, within it, whoops, if I expand the larger, I thought that was n minus 1. This is larger, I get the following, all the way down the line, and this is n factorial, which will cancel with that other one. With the 8 and the 7, I'm just curious, how many of you see that what we're going to end up with is just the number 8 on the right-hand side? Because we can do the same thing with these even though they're just numbers. this is 7 factorial. So I divide both sides by n factorial. I divide both sides by 7 factorial. And I'm left with 1 equals n plus 1 over 8. I can multiply both sides by 8. This is kind of a disappointing question because it just simplifies to almost nothing. And then I can say n is equal to 7. Is that okay? Okay. Any other questions before we get going here? Yeah, Annalie. 5b. Okay, we have to choose 11 players from 17. Jeff and Brent cannot both be selected. Does that mean that Jeff can't be selected? No. Jeff can be selected as long as Brent is not. Similarly, Brent can be selected as long as Jeff is not. So we have teams or squads. We have 11 member selections with Jeff and not Brent, or Brent and not Jeff. Are there any other possibilities? All right. Or, and there's lots of ways to communicate this. I'm not saying that what I'm writing is how I'm going to be doing the calculation. When it comes to this last one, I'm just going to think of it entirely different. But we have 3 possibilities. So Jeff and, well, let's do this. There's a Jeff, there's a Brent, and there's 15 other players, right? So if I want one Jeff, I'm going to, for sure. Because you need 11 total. And we only have, in the first line, we only have Jeff, which is 1. We need 10 more. In the second line, we only have Brent, which is 1. We need 10 more. I apologize. I'll get it straightened out. Yep.
If I just did all of them minus what I calculated in part A.
Yeah. I did it this way because you're not always going to be able to do that, or it won't always be as economical as it is in this case. But in part A, even though they didn't mention Jeff and Brent, if you figured out how many squads they are both on, and take it away from 17, choose 11, then you're going to get the number where they're not both on, which means they might one be on or the other on, but not together. Is that okay, Annalie? Sorry for my foul up there. Any other questions? Okay, we are going to be going through the binomial theorem here. We're going to be going through the binomial theorem today and tomorrow. I break it into 2 parts. I think I could easily go into 1 part here, but I think I would lose more people if I didn't, or if I did that. So we're going to be using Pascal's triangle to expand out x plus y to the n. What does that mean? It means, if I said, what is x plus y squared? Well, that's pretty easy, isn't it? It's x plus y times x plus y. And we could FOIL that out. No problem. If I said to you, what is x plus y to the 6? We could do that. You could do that. Nobody wants to do that, but you could. What you would do is say to yourself, that's what it is, and you would say that this, and I'm not going to do this, is that, because when you FOIL out and simplify x plus y squared, that's what you get. And then what you would end up saying is, you need to FOIL that out. Think about what's involved there. You would need to multiply, and I'm not going to do this. This times this times this times this, write it down. This times this times this times this, write it down. This times this times this times this, write it down, right? And then you're going to have 9 terms that you're going to add together, and some of them will be like terms. But then you'll simplify it, and then you're going to have to do with that and the x squared plus 2xy plus y squared the same thing we just did. Okay, well, there's a shortcut, so we're not going to be doing that, luckily. If there wasn't a shortcut, it wouldn't be in the course. We wouldn't waste time doing that. Same thing with this, 2a minus 4b raised to the 4. We know how we would do it, but we don't want to. It's just too much work. And honestly, if we did even this, I think most people will make a mistake someplace. It's just too easy to make a mistake. You'll get bored and tired and stop focusing. So we're going to start off here by looking at something called Pascal's Triangle. And it could be any binomial raised to any exponent. This is Pascal's Triangle. Now I have a grid there so you can keep the numbers organized, but I'm going to give you a minute to see if you can figure out how you can figure out the row entries by looking at the row above the row that you're interested in. And when you see the pattern, just put up your hand so that I know you see the pattern. I mean, the next row's got to start with a 1 and end with a 1, right? I mean, if you don't see the pattern, this is it. This is a honeycomb style instead of just squares, but the idea is to find a missing entry, you add the 2 entries that are adjacent to it. So this would be a 1, this would be a 5, this would be a 10, this would be a 10, this would be a 5, this would be a 1. And we are asked to, I believe, put the entries in for the next 3 rows. Is that correct? 4, okay? So there's 1. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 15, 6, and 1. You do notice, by the way, that if there is an even, I hope, if there's an even number of numbers in the row, then it's perfectly symmetrical, right? 1, 5, 10, 10, 5, 1. If there's an odd number of numbers in the row, then it is symmetrical except that you have a number that's different in the middle. So it's 1, 6, 15, and then there's that 20, which doesn't have another 20 anywhere, 1, and then 15, 6, 1. So that's what we would continue to do. This would be 7, this would be 21, this would be 35, this would be 35, 21, 7. I admit I sometimes just get into autopilot here, so when I get to the next row, I'm going to want you to, is this right? Is that right? Okay, I'm going to want you to double check everything. 8, 28, I guess that's 56, 70, 56. How did I do with my addition?
The 1 on the bottom should be moved over, there should be an 8 there.
That's what was wrong. I didn't finish this, did I? Okay. So this is a 1, this is an 8, 28, 56, 70. So something wasn't lined up there. Does that look okay now, Annalie? Okay. So it's a neat little pattern. If we had time, you could have a whole interesting full lecture on Pascal's Triangle. There's all kinds of interesting stuff buried in this. But we don't. We're going to use it for one sole purpose. I would like everybody to notice that if I took the binomial x plus y and I raised it to the 0, I get 1. I want you to notice that the exponent on this binomial is 0, and I get 1 term. If I were to take the binomial x plus y and raise it to the 1, that means I'm going to get x plus y. Are you with me? I want you to notice the exponent on x plus y to the 1 is 1, and I get 2 terms. If I have x plus y squared, the exponent on x plus y is a 2, and if you FOIL that out, you get x squared plus 2x plus 2, plus y squared rather, you get 3 terms. So the thing I'm pointing out to you, and we're going to figure out what this one is, the thing I want to point out to you is whatever the exponent on the binomial is, you get 1 more term in the expansion. Are you with me on that? Okay. So what is x plus y cubed? Well, I guess we could go, you don't have to do this, just watch me do it. X plus y times x plus y times x plus y. We know this is x squared plus 2xy plus y squared. So I have to,
I think ours is to the 4.
is it to the 4?
Yeah. No. We have it. Yeah. Ours goes.
Oh, I show you to the 3. Okay, yeah.
Oh, okay,
Yeah. I'm going to do this anyway just to show it to you, and then we'll get to the 4. We are not going to figure out x plus y to the 4 doing this. Okay? So I'm still just working on filling in that bottom row. X squared times x is x cubed. X squared times y is x squared y. 2xy times x is 2x squared y. 2xy times y is 2xy squared. Y squared times x is xy squared, and y squared times y is y cubed. So you get, and what you should have written there, it's already in there, right, is 1x cubed plus 3x squared y plus 3xy squared plus y cubed. Yes? Okay. Oh, I wasted all that time. Look at that. I had it all here ready to go. But it leads us to this. Do you notice something else about the expansions here, other than the fact that you get 1 more term than the exponent of the expansion? I'll give you a hint. It's in how I've arranged this visually. Isaac?
The exponents themselves are just like the example above. If, no, I don't know.
Thomas?
Kind of mirrors Pascal's triangle.
Yeah. In fact, it mirrors it perfectly. The first row of Pascal's triangle is 1. The second row is 1, 1. The third row is 1, 2, 1. The fourth row is 1, 3, 3, 1. And that is going to be always the case for x plus y to the n. I also want you to notice, we can start off with the x plus y cubed. X is raised to the 3 in the first term, x is raised to the 2 in the second, x is raised to the 1 in the third, and in the last term, x is raised to the 0. It goes from x to the 3 to x to the 2 to x to the 1 to x to the 0. And y goes from y to the 0 to y to the 1 to y to the 2 to y to the 3. Notice, by the way, this gets a little bit tricky, but in tomorrow's lessons we'll be able to bypass it a little bit for some of you, that since the number of terms in the expansion is 1 more than the exponent, then you look at 1 more than the exponent for a row number for the numbers. Meaning, which row of Pascal's triangle do you look at for x plus y cubed? You look at the 4th row, because it has 4 terms. So now we get to this. What is this going to expand to give? Well, there's going to be 5 terms, which means we look at the 5th row, which I believe is 1, 4, 6, 10, no. Help me out.
1, 4, 6, 4, 1.
1, 4, 6, 4, 1. That's the 5th row. One, 4, 6, 4, 1. So you're going to end up with 1 x to the 4. all of these are owned by x in the first term. The second term is going to have a coefficient of 4, but x will only own 3 of those, and y will own 1. You certainly don't need to write y to the 1. And you definitely don't need to write y to the 0. Plus, the next term will be 6. And the pattern here, I hope you're catching on, is that x keeps dropping by 1 for an exponent and y keeps increasing by 1. And then we're going to keep going until we run out of exponents to steal from x. So we take one more away from x. We take one more away from x. And if you've done things properly, you should run out of exponents when you hit the end of the row in Pascal's triangle. And that's the answer. I'm going to highlight for you things that we would not need to write. You wouldn't need to write y to the 0. You certainly wouldn't need to write any 1s. You wouldn't need to write x to the 0. So you don't have to rewrite it, but all of those things I've highlighted are not necessary. So, if you turn the page, when we expand x plus y to the n, without using a formula, because there's a formula we will learn in the next lesson, okay? There will always be n plus 1 terms. If you're expanding x plus y to the 12, there's going to be 13 terms. You're going to look at that row number in Pascal's triangle. So if we're expanding x plus y to the 12, you need to know the numbers in the 13th row of Pascal's triangle, which would be a real pain, wouldn't it? Okay? Which is why the formula we will learn in the next lesson relieves the pressure a bit. The first term will contain x to the n and y to the 0, and each subsequent term will have one fewer on x and one more on y until you get to x to the 0, y to the n. It's pretty simple, actually. It gets a little bit more complicated, but any questions right now before we get into the examples? Okay. What is x plus y to the 5? Is that what you have, is x plus y to the 5? I'll tell you what, let's change that to x minus y to the 5. So, what we need to do here is recognize that all of those rules we just gave work if you have a thing plus a thing raised to the n. Okay? So what we have to do here is think of the first part as being x and the second part as being negative y. In other words, well, we're going to look at the 6th row of Pascal's triangle, which is 1, 7, 10, 15, 10, 7, 1. Probably not. Oh, the 5th row? 6th row, rather.
1, 5, 10, 10, 5.
1, 5, 10, 10, 5, 1. So I'm just going to write that here. 1, 5, 10, 10, 5, 1. So what we're going to do is say there's 1 x to the 5, and there are no negative y's. We're going to just throw that negative on the y as opposed to putting it as a minus sign. And then we're going to have 5. We will have x to the 4, and we will have negative y to the 1. And my recommendation is always to put negatives in brackets. Then we're going to have 10 x cubed negative y squared. Then we're going to have 5 x squared negative y. Nope, we have another 10. 10 x squared negative y cubed. And by the way, everybody, along the way, there's a couple of internal checks that you can do. Your sum of the exponents will always add up to n, in this case 5. Then we have, now we're down to 5, and it will be x to the 1, negative y to the 4, and then plus 1, x to the 0, negative y to the 5. We could, if we wanted to, just double check these quickly. Are the coefficients 1, 5, 10, 10, 5, 1? Yes. Does x start off at 5 and then go to 4 to 3 to 2 to 1 to 0? Does y start off at 0 and go from 0 to 1 to 2 to 3 to 4 to 5? Do we have 6 terms? Yes. So we simplify it. Do you see the significance of putting that negative y in brackets? Because if it's raised to an even number, the term will become positive. If it's raised to an odd number, the term will become negative. So this becomes x to the 5 minus 5x to the 4y plus 10x cubed y squared minus 10x squared y cubed plus 5y xy to the 4 plus, no, minus y to the 5. Okay with that? B. Is this your B? Okay. So what we're going to do here is this. It's not x plus y. It's 3r minus 2t. So we're going to say x is 3r. We're going to say y is negative 2t. And we know that n is equal to 5. So we're going to go to the 6th row again. It does matter what row it is. It doesn't matter whether I say to the 5 or the 6. We could do it. But I'm using the 6th row again. That way we have those numbers in our head. 1, 5, 10, 10, 5, 1. Okay. So my first term will contain a 1, and then it will contain an x, which is 3r, raised to the 5. And it will contain negative 2t raised to the 0. I just want to throw something out here right now. Do you see that the coefficient of the first term is not only determined by the number from the row in Pascal's triangle, but it's going to be determined by that 3 as well? Because it will be 3 to the 5. Go ahead.
If we write down the 0 or to the 1 on the diploma or something, maybe we get it wrong.
No. If you did that, that's fine. You don't even need to put it if it's to the 0.
But if you do put it there, it doesn't matter?
No, that's right. I like to put it there when I'm kind of in teaching mode, because then I can say, look at that, the exponents add up to n. Okay? And then we're just going to keep going. 5 is the next number. Then we're going to have 3r raised to the 4 and negative 2t raised to the 1. The most complicated part of this, I would say to you, is the tedium. It's tedious. It's just, you lose interest after a while. Mind you, for some people, that's what math is all about. Hopefully not anybody here. But it is easy to lose interest in this. Then we have 10. You continue working. I'll do the same thing up here. And then we can compare our answers. I'm going to double check 5, 4, 3, 2, 1, 0 for the 3 r's, 0, 1, 2, 3, 4, 5 for the negative 2 t's. Coefficients from Pascal's triangle, 1, 5, 10, 10, 5, 1. I think we're okay. So now, and there's a lot I could write here, but I think less is more here, less is better. You need to understand, everybody, that this raised to the 5 and this raised to the 0 and this number 1 together are going to be what truly determines the coefficient of that first term. So you need to take 1 times 3 to the 5 times negative 2 to the 0. In other words, it's 3 to the 5. And I believe that's 243. While I do some of this in my head, I'm going to want a few people to confirm that my arithmetic is correct. In the second term, the coefficient is going to be determined by this 5, by the negative 2 to the 1, and by the 3 to the 4. So you need to take 3 to the 4 times 5 times negative 2, and I believe you get, well, 81, negative 810. Yes. So you're going to get negative 810. I'm going to stop with the highlighting. It will be r to the 4 times t to the 1. This next term is going to be positive because that negative factor is squared. You need to take 10 times 3 cubed times negative 2 quantity squared. I want to say 1,080. Thank you. Plus 1,080. This will be r cubed t. So I'm here now, squared. And then here, this one will be negative because we have negative 2t raised to an odd exponent. You need to take 10 times 3 squared times negative 2 quantity cubed. And I want to say negative 720. Okay. And that will be r squared t cubed. If you ever lose track, just look at the previous term and use the exponents you had. 4, 1 changes to 3, 2, changes to 2, 3. This next term is going to contain a coefficient of 5 times 3 to the 1 times negative 2 quantity to the 4. $240. Thank you. Took a little longer for me for that one. And then here we're going to have negative 2 to the 5 being the only significant contributor to the coefficient, and you get negative 32 t to the 5. Any questions with that one? Okay. Would you agree that this is tedious? It's not a lot of fun. It's not very engaging. What if I said to you that in, what was this? This was 3r minus 2t raised to the 5. What if I said to you, what's the fourth term? What's this term? And you could do it without going to Pascal's triangle, and you could do it without looking at the first term to find the second term, to find the third term, to find the fourth term. Well, I think you'd be interested in that. So let's turn the page, please. And we're going to notice something. That I'm going to pick on the fourth row of Pascal's triangle, which is right here. It's the fourth row of Pascal's triangle, which, by the way, is 1, 3, 3, 1. Do you agree if you flip back and look at the fourth row? Well, it turns out that 3 choose 1 gives you 1, 3 choose 3 choose 0 gives you 1, and then 3 choose 1 is 3, 3 choose 2 is 3, and 3 choose 3 is 1. Now, let's just stop for a second and explore why, even though we're choosing out of 3, why you get 4 different possibilities. Well, because you can choose none, or 1, or 2, or 3. So if I said to you, and I think the last row in Pascal's triangle we did was what, the 8th row on the first page? Was it the 8th row? Okay. So if I said, what is the 8th row? You would say, well, I need to start off with something choose 0, but I need 8 options. Well, that means it's 7 choose 0. The next one will be 7, choose 1, 7, choose 2, 7, choose 3. Go ahead and figure out what 7, choose 3 is on your calculator. And look at the 4th entry in that 8th row. The same number. And I want you to notice, everybody, that since this row would contain 8 terms, this row has to do with a binomial raised to the 7. Because you get one more term than n. Which means if I have a plus b raised to the 9, the coefficients I'm going to use will be 8 choose 0, 8 choose 1, 8 choose 2, 8 choose 3, all the way up to 8 choose 8. If I have raised to the 7, the coefficients are going to be 7 choose 0, or sorry, this would be 9 choose 0, all the way up to 9 choose 9. If it's to the 7, it's going to be 7 choose 0, all the way up to 7 choose 7. And we don't have to add that extra number. There's something else a little weird going on, though. Okay? And I'm going to use, before we finish this off today, I'm going to use this last example to demonstrate this to you. Let's take, it doesn't matter which term. I'm going to take this term here. If this was raised to the 5, right? Is 5 choose 0, 1? Okay. Is 5 choose 1, 5? Is 5 choose 2, 10? Okay. So, this term is 5 choose 2. It contains x raised to an exponent, and it contains y raised to the 2. I want to point out to you that these numbers will always be the same. Are you with me? And the exponent on x has to be the difference between these two numbers, because these two exponents have to add to give 5. And that means that this is a 3. The last piece of the puzzle, and then in the next lesson we'll formalize this with a formula. The last piece of the puzzle is recognizing this. This is the key to any term, but it's one less than the term number. First term has a key number of 0. Second term has a key number of 1. Third term has a key number of 2. Let's just practice this with one final example. What is the 5th term in this expansion? Well, we know it's going to be a combination followed by x raised to an exponent followed by y raised to an exponent. Would you agree? Okay. The number you're choosing from is always the exponent on the binomial. And the number you're choosing, and I'm going to call this the key number. The number you're choosing is one less than the term number. This is an important feature. We just need to know that. If you want to find the 8th term, you put 7 here. We're after the 5th term, so the key number is 4. But that key number must be the same as the number of the exponent on y. It's always going to be the same, which means this is 4. And the exponent on x has to add to that 4 to give you n. This is the term. Whoops. This is the term. You can figure it out. I mean, the coefficient will be 9 choose 4 times 2 to the 5 times negative 3 to the 4 All of those things will contribute to the coefficient. The variables will be x to the 5 and y to the 4. And quite frankly, I don't care what this number is. You could work it out. That's not the point. If I gave you just one more quick example, if I gave you 2y plus 7r raised to the 8, and I said, what is the third term? Then the fact that I'm saying the third term means the key number is 2, and we actually do use the letter K for the key number. Can you tell me what n is? What is n in this example I just wrote? 8. And here's an important thing. N is 8 for every term. N is 8 for the first term, n is 8 for the second, n is 8 for all 9 of these terms. But each term has its own key number. So what is the third term? It is 8, choose the key number, times x, raised to an exponent, times y, raised to the key number, and this exponent needs to add to 2 to get 8. That's the term. And we don't have to write out a whole bunch of rows of Pascal's triangle each time. We just have it. There's actually going to be a formula that's on your formula sheet that will do that for you.